We present ViSER, an interactive visual analytics tool for visualizing supply chains for the purpose of eco-conscious redesign. ViSER provides a visualization dashboard consisting of multiple mutually coordinated views that provide different perspectives on a particular supply chain scenario. This screenshot illustrates the core functionalities of the tool. This prototype tool, based on the ViSER framework, was built on Processing 2.1, a Java-based open-source programming platform. In Part A, we see a tree graph of a supply chain network. This particular representation is attractive since this supply chain is cyclic in nature. In Part B, the user can dynamically interact with the product system graph via a force-directed layout in order to improve the graph's overall representation. Selections in either graph are acceptable. Part C provides a snapshot of the change propagation index of all selected entities. In D, the user can survey selections from the perspective of Tracy impact damage categories. Within Part E, the user can quickly understand the general profile of each criteria through spark lines. And finally, in Part F, based on the user selection, a large sortable bar chart shows a particular user selection with respect to the attribute values of the other nodes. To demonstrate the utility of ViSER, we conduct a use case scenario of a hypothetical user. Mark is a project manager at a computer casing manufacturer with extensive experience as an LCA interpreter and practitioner. In other words, Mark can balance the performance of a product among several environmental damage categories. Mark is asked by upper management to report on the environmental hotspots associated with the product so that his company can be positioned better for imminent regulations. Mark loads the supply chain and product system graphs of product X for initial surveying. He scrolls over entities of interest to understand their general connectivity within the graphs. Mark then analyzes the spark lines for each LCA impact criteria to see which category shows a significant number of anomalies. He chooses smog as a criterion of interest. Immediately, Mark notices the largest contributor to smog in the product system. He chooses the particular node and reads the information provided by the detailed tooltip. Mark notices that the entity represents a transportation stage. As a result, he chooses another significant contributing transportation stage for comparison. Next, Mark decides to choose the second highest contributor to smog and happens to be a component procurement stage. He then selects a specific stage of interest for which he knows has potential for improvement. Now, Mark would like to see how these supply chain stages rank in terms of the amount of time required for procurement. He selects both stage time and smog as the two criteria to view. Mark notices that Part 1, shown in green, has significant potential improvements in both criteria. As a result, he begins to plan out specific redesign activities for that particular component. Thank you for your attention. Please refer to the paper for more details.